Hey there, and welcome to today's Explainer. I am so incredibly thrilled you're tuning in because today we are tackling a topic that, sometimes makes people a little anxious, but it absolutely shouldn't. We are officially demystifying fractions, and my promise to you right out of the gate is this. We're going to make fractions completely relatable and honestly entirely stress-free by using simple, real-world examples that you already interact with literally every single day. We're going to unlock exactly how fractions work. You'll see there's absolutely nothing to be afraid of.
Okay, so here's our roadmap for this explainer. First, we'll look at the anatomy of a fraction. Then, we'll check out the three types of fractions. After that, we'll unpack equivalent fractions, how to compare fraction sizes, and how to add and subtract them. Finally, we'll wrap up with some real-world fraction action. We're just going to take this one simple step at a time.
All right, let's dive right into Section 1, Anatomy of a Fraction. Basically, what exactly makes up a fraction?
At its core, a fraction is really just two numbers separated by a line. And, we've got specific names for these numbers. The top number is the numerator. That tells us how many parts we actually have in our hands. The bottom number, well, that's the denominator, and it tells us how many equal parts the whole object is divided into. So just remember, top number is what you have, bottom number is the total parts available.
Let's make this visual. Imagine a totally delicious pizza cut into 8 equal slices. Now, if you go ahead and eat 3 of those slices, because why wouldn't you, how do we actually write that down? Well, the number of slices you had, the parts we have, is 3. So 3 is our numerator. And the total number of equal slices that made up the entire pizza was 8. So 8 is our denominator. You ate 3 over 8, or 3/8 of the pizza. See? It really is that straightforward. Moving right along to Section 2, the 3 types of fractions. We're going to look at proper, improper, and mixed fractions.
Okay, so on the left, we've got proper fractions. This is your classic setup where the numerator is smaller than the denominator, like 3/4 or 1/2. Visually, this means you have less than one whole. It's our partially eaten pizza. But on the right, we've got improper fractions. This happens when the numerator is equal to or actually larger than the denominator. Think 5/4 or 7/3. This represents one whole or even more. So instead of a partially eaten pizza, an improper fraction means you literally have more slices than a single whole pizza even contains. Crazy, right?
And that brings us to our third flavor, mixed numbers. Now, a mixed number is just a whole number combined with a proper fraction, like 1 1/4. But here's a little secret. A mixed number is really just an improper fraction in disguise. Having one whole pizza plus a quarter of another pizza is the exact same value as having 5 individual quarter slices. They represent the exact same amount, they're just written a little differently.
Now for Section 3, Equivalent Fractions Explained. Let's look at what I like to call the illusion of difference.
What's really interesting about this is how it completely proves this illusion. We've got 3 identical bars here, but each one is cut up differently. The first is split into 2 parts, with 1 shaded in, so that's 1/2. The second is split into 4 parts, with 2 shaded, which is 2/4, and the third is split into 8 parts with 4 shaded, giving us 4/8. But look closely at the shaded areas. 1/2, 2/4, and 4/8 all take up the exact same visual space. They are entirely equal.
So how do we figure this out without having to draw bars every single time? Well, here is the golden rule of equivalency. You multiply or divide the numerator and the denominator by the exact same number to find an equivalent fraction. Whatever math you do to the top number, you absolutely must do to the bottom number. So if you multiply the top of 1/2 by 2 and the bottom by 2, you get 2/4. That is the secret to unlocking equivalent fractions.
All right, Section 4, Comparing Fraction Sizes. Basically, which one is bigger?
Think of this like a showdown to figure out which fraction gets you the bigger piece of dessert. First up, let's look at a showdown where the denominators are exactly the same. We're comparing 3/5 and 2/5. Notice that both of these shapes are split into 5 equal parts. When the denominators match like this, you can just compare the numerators directly. It's just simple logic, right? 3 shaded parts is obviously more than 2 shaded parts out of the same total of 5. So, bam, 3/5 is greater than 2/5.
But what if the denominators are different? Well, this brilliantly illustrates what happens when we compare 1/2 and 1/3. Now, one way to solve this is by finding a common denominator. But another incredibly effective way is just using a visual size comparison. By drawing 2 equal length shapes and shading 1/2 of one and 1/3 of the other, it easily and visibly proves that 1/2 is, well, bigger than 1/3.
Another great visualization tool is placing fractions on a number line. By drawing a line from 0 to 1, you can map out exactly where fractions like 1/4, 1/2, and 3/4 actually land. Placing them on a number line between 0 and 1 helps you instantly compare their sizes right at a glance. You can clearly see the progression, and it makes total sense how 3/4 is much closer to a whole than 1/2 is.
Moving into Section 5, adding and subtracting fractions, it is time for the math mechanics. My absolute promise to you is this. If you can count slices of pizza, you can easily add and subtract fractions. Let's walk through these mechanics like a foolproof recipe. Step 1, check if your denominators match. If they do, awesome. You're ready for Step 2, which is simply to add or subtract your numerators. Finally, Step 3, and this is absolutely crucial. You keep the denominator exactly the same. The denominator never changes here, because think about it. The size of the slices hasn't changed.
For example, let's add 1/4 and 2/4. Following our recipe, the denominators match, so we just leave that 4 alone. Then we add the numerators. 1 plus 2 is 3. Visually, combining 1 slice and 2 slices of a 4-slice pizza gives us 3 slices, or 3/4 total. It is incredibly straightforward when you actually see it drawn out like this.
And guess what? We can apply the exact same logic to subtraction. Look at 3/5 minus 1/5. The denominators are both 5, so we just subtract the numerators. 3 minus 1 equals 2, giving us 2/5. Just think of it like a candy bar that has 5 pieces. If you have a portion of 3 pieces and you take 1 piece away from it, you are left with exactly 2 pieces out of the original 5. Easy!
Finally, we've made it to Section 6, Real-World Fraction Action. Let's see how this all builds into everyday math. Let me give you a highly relatable dilemma to really engage those newly learned skills. Imagine it's a birthday party. You've got this beautiful cake and you need to share it equally among yourself and your friends. How do you figure out how much cake each person actually gets? Well, you use fractions, of course.
To answer that question, if you're sharing that single whole cake among 6 friends equally, every single person gets 1/6 of the cake. The cake is the whole, and the 6 friends, they act as the denominator. And honestly, we see this everywhere. Cutting a sandwich in half and giving 1 piece away, that means giving away 1/2. Or baking a recipe that needs 3/4 of a cup of sugar, you immediately visualize a measuring cup marked with those fraction lines. These practical, everyday examples prove that fractions exist literally everywhere, from your kitchen to your lunchbox.
As we wrap up this explainer, let's quickly recap our core takeaways. A fraction is always just a part of a whole, made up of a numerator on top and a denominator on the bottom. We've got proper, improper, and mixed fractions to describe their size. Equivalent fractions show the exact same value but in different forms, and we know that comparing them is an absolute breeze when we visualize bars or number lines. Finally, adding and subtracting is as simple as combining numerators as long as those denominators match. Visualizing bars and pizzas truly makes all these rules just click into place.
I want to leave you with this provocative thought. Next time you break a chocolate bar, will you just see a tasty snack or a math problem waiting to be solved? You now have the tools to look at the world totally differently. You're empowered to see the fractions operating all around you. I really hope you found this explainer helpful and that you're leaving hungry for even more learning, seeing the world through a brand new mathematical lens.